the global pipe market for HDPE was a $21 billion market. They project that to be 34 billion in 2032. So we know we're growing, we're taking market share for sure. I think anywhere where there's infrastructure that has to be done and people want, back to our key buzzwords, sustainability, right? They want a pipeline that's going to last a long time. HDPE is a great solution for sure.
Greetings, Peter Dyke here for another edition of the Poly Podcast. With me today is Dan Landy. Hello, Dan.
Hey, Pete. Good to see you again. Busy week.
Yeah, busy week. Well, Dan, they've all been busy lately.
Yeah.
And you and I were together here this week, and we kind of felt that it'd be a good time to talk about big pipe again. You know, we had Mike James on 5 years ago, Dan. So he hasn't been on the podcast in 5 years. I mean, all the COVID years, no Mike James, except he has been a guest on our webinar series. And we've been really very successful. We've been doing 2 webinars a year on larger pipe. And kind of, Dan, the yardstick is changing. We used to say 24-inch, then we said 36. And now, particularly in the webinars, we're saying 48-inch is what big pipe is.
Yeah, I never know what big pipe is. When people say that, I'm like, what is big pipe to everybody? Because, not everyone operates a 30-inch line. I feel like we've grown a lot. A lot of people consider that medium. I consider that a big pipe still.
Yeah, well, I consider 48 big, but talking to some of these experts that are dealing with customers every day, 24 and 36 is just pretty routine anymore. But I kind of feel it's not true with electrofusion, but I feel it is true with smooth wall pressure pipe that 48 is pretty big, 36 not so much. But I do feel that electrofusion is big, just because when you're doing electrofusion, it's a whole process that you got to pay super close attention to.
Yeah, and tie-ins are never going to be easy. Regardless of what you're transitioning material-wise, they're always difficult handoff points. But ISCO does have that nice 3-jaw machine. I know they don't post it a ton. I don't know if I should have said that, but I'm thinking we should probably edit that out.
No, I think we should ask Mike James about it. The other thing which I think is interesting over time, you look back to 5 years ago when Mike James was last on, we were just starting the webinar program, and we were having hundreds of people, and people would say, yeah, your webinar program, that's great now, but it's going to die. Tell us about the webinar yesterday.
Yeah, yesterday we did casings and crossings. So if you're doing a horizontal directional drill, you need a conductor pipe, typically to get down to a buried depth of when you can actually drill. You can't really drill through sands and muck and mud and other type of stuff. So that's one case scenario. If you have to jack and bore under a highway, you're typically using a steel conductor pipe or steel casing. So basically looking at grouting the angular space between steel and polyethylene. Do you need spacers? What kind of flowable fills do we like? We've never really gone into the nitty-gritty details of pipeline design on those, so it was really good to tackle it for the first time.
Well, you came up with that idea to do that as a podcast. We had 560 some people sign up, and we got a yield of close to 60%. So we had 325 people on there, Dan. And so here we are 5 years later, still talking to hundreds of people on these webinars.
Yeah, and I think it's interesting because people are now starting. I think we had to go, turn over every stone to see what people's interests were. Where now it seems like people are naturally gravitating towards polyethylene. As you know, I was out in Corvallis, Oregon, and they did that awesome project. We weren't involved in it. They had been attending our webinars, but the one thing that really interests them was seismic resistance. They're out west. They're getting a lot of pressure from, utility directors and what's that word your buddy Jim likes? It's not sustainability, resiliency. Resiliency out west is really becoming the big buzzword for water infrastructure. So everyone's kind of finding it for a different reason, but it's really just important that they are.
Well, I think it's important we keep talking about it, and that's why I'm so thankful that Mike James is willing to do that. Mike James, ISCO Industries Vice President, please come on the line.
Good morning, gentlemen. How are you?
Hey, Mike.
Fantastic, wonderful, and always great to talk to you, Mike. Where are you coming to us from today?
Well, at the moment in Tucson, Arizona, the desert where I live, love it out here, especially when winter hits, but getting ready to board a plane for a very long flight. I'm going to a pipeline conference over in Turkey, actually, with some of the biggest contractors in the world and talking about pipes. So it'll be fun.
Nice. So, tell me about polyethylene's reputation in other parts of the world. We spend a lot of time, Mike, talking about it here in the U.S. and Canada. What's it like in other parts of the world?
Yeah, as I get to travel globally occasionally, it's good to kind of see what's going on globally with pipes in general and also with HDPE. And I'll tell you, globally, we're lagging behind in North America. It's hard to believe that, but we are. You go to Asia, you go to the Middle East, you even go to South America, they're doing some really cool things with HDPE pipe over there in some really large diameters. And the adoption rate over there is really high. Dan, you just hit on a couple of key buzzwords. The reason they're using it over there is for sustainability and resiliency and all of the benefits that we know about, but they're using it over there for a lot of those same reasons.
Yeah, I forgot that's a lot of the seismic areas as well, right?
For sure. Yeah, the Ring of Fire. I mean, anywhere you've got seismic zones, whether it's, New Zealand or Chile or Australia or Japan or whatever, there's a lot of benefits for HDPE pipe there. But beyond that, big industrial projects or water lines, you go to Europe, they use it all the time for gas, sewer, water. Um, we kind of pull that technology into North America, right, and use it here. So what we're doing today is really cool. And in our discussion 5 years ago to where we are today, we've made a lot of headway, which is really good. But we still have more improvements to make, but we've come a long ways, Peter, which is great.
Yeah, I really think we have, and that's kind of one of the things I want to get into today, Mike. But briefly, could you tell the audience who you are and what you do?
Sure. Mike James, I've been in the HDPE industry probably longer than Dan's been alive. I don't know. Dan, you're a pretty young guy, but for a long time. And it's a passion of mine. I grew up in the construction field. My dad was a contractor. I navigated into the pipe business and have been in the HDPE business for 30 plus years. My title is Vice President of Sales and Business Development. I help our team in the West. I do a lot of business development, do a lot of networking, a lot of problem solving, and really a lot of education as well. That's one of the key things I want to do is make sure we're continually educating our customers, our engineers, our contractors, and our own staff as well.
Yeah, Dan and Alan and I have really picked up on what you just said, Mike, is educating our own staff. Um, I've said for years, we have to do a better job training our own people. So it's not necessarily we need more evangelists like the Alliance staff, but the more our team knows, the better they're going to service our mutual customers.
Yeah, and old guys like you and me, Peter, we get to have some fun with the young guys like Dan, right? The up and coming, the next generation, the next leaders of our industry. It's fun to be able to work with them and show them some things that we've learned just through tacit knowledge and over our years of experience.
Yeah, for sure. Well, Mike, I don't really want to retread what we talked about 5 years ago because, frankly, I can't remember. But you and I have been talking about big pipe for 5 years. You've probably been doing it for 10 or 20. And there was a time when a 24-inch DR21 was a big deal. This year, we're going to do our first 63-inch DR11. So, to those that know diameter in DR, that's a huge deal. What are you seeing from 30,000 feet in the United States and Canada?
Yeah, I think if we did go back 5 years ago or even beyond, I mean, 24 and 36-inch pipe, that was a big deal. And I tell the story often. I told it on the podcast years ago, and I tell it a lot still. I remember buying our first 36-inch fusion machine, and that was a big deal. That was kind of the size range. Our pipe was being used a lot. Maybe 42 or 48 inch would be used. Today, that's just commonplace. We do bazillion miles of 36-inch pipe every year, but we're seeing 42, 48, heavier walls, higher pressures, 54. Peter, we're getting into much larger diameters than that as the capabilities and the technology is driving that here in North America. You and I have talked about some projects that we'll talk about here in a minute where we're in the 78, 80 plus inch range. We've got some projects on the horizon that are over 100-inch in diameter. So that's becoming the norm for us. And that's where, as I see globally, the rest of the world is already doing that stuff a lot. So that's where we're at now, which is great.
Well, you mentioned 36 inch. So I've got some data here from one of my pipe converters. So Converter is a company that makes polyethylene pipe. And the growth from 2023 to today, so a 2-year growth in 36-inch diameter is 134%.
Wow. Yeah, I believe it. I believe it.
So across 2 years, you're going up, 65% a year in just the 36-inch diameter. That's dips and ips and all
Yep.
DRs. So the market, obviously, Mike, is paying attention. I mean, we're not taking credit for any of it, but the market's paying attention to our ability to make 36-inch diameter bigger and stronger. Who is the market? What market is this, and who are they?
Well, I think you should take some credit because the alliance and the educational side of the alliance and what we've been doing for years, planting seeds and educating engineers, owners, contractors, that's part of the reason, right? People have adopted and they understand the benefits of HDP. It's not for every single pipeline. We know that. There's a place for every type of pipe out there, but people are starting to realize all of the advantages, the corrosion, the resiliency, the sustainability, the flexibility, the leak-free, zero leaks, leak-free joints, right? I mean, that's huge. And I think as we are seeing municipalities and engineers get educated, they're starting to understand, and the light bulb's going off. That's why it's growing.
Okay, but who are they? So we got 9 major markets. Conduit, we're not doing 36-inch conduit. Water, I know, does it. Who's doing it? What market likes 36-inch?
Well, I will tell you, we are doing some conduit in larger diameters, maybe not 36-inch, but there's a lot of data being done, a lot of underground conduits being put in. And sometimes with Dan, what you talked about a second ago, casing pipe, right? They're using our pipe, HDPE pipe, for casing and shoving a bunch of conduits inside of that, right? For big data centers and things like that. So there is some growth in that. Probably not the biggest growth, but certainly municipalities, water, sewer. I would say the industrial market has already kind of been using it, but certainly I think it's growing in the municipal market, but it's also growing in the energy market too. We're seeing larger diameter pipes being used in the oil and gas and the energy in the water transmission there as well. Maybe not up to 36-inch necessarily, but certainly in the 20 and 24-inch diameters. And that's the reason we're creating tools and equipment to work in that space as well.
So what does energy mean?
Well, anywhere you're pulling out oil and gas to turn on the lights here in America.
Okay.
You've got water. You got to transport a lot of water when you do that as well.
So not nuclear power plants. You're not power plants. I know they use
Power
polyethylene.
plants for sure. Yeah.
Does that count as energy, or is that industrial?
Yeah, a different type of energy, but I would throw that in the same bucket for sure.
Okay. So in the water space, it's kind of interesting. When I first started doing this 15 years ago, we had a very narrow focus. It was municipalities. And at that time, it was just, okay, is it a municipal government? Is it a water utility? Does it do water, sewer? Now, we consider water to be irrigation. So we do a lot with irrigation entities, as I'm sure you do out west. Tell us a little bit about that market and how polyethylene is making inroads there.
Yeah, that's a big growth market for sure, especially in the West and arid climates where I live in Arizona, for example, but anywhere really in the West. So uh, canal conversions are a big space for large diameter pipe. And so I'll give you an example. We've got a couple of projects that we're working on right now. We just are working on a job here in Arizona, a couple hours from me, where they don't have any pipe at all. It's just an open ditch canal. And their water loss and evaporation is huge, Peter. I think we talk about that. It's probably 30 to 40% water loss, right? So when water is so valuable to us here, especially in the desert, that's critical. So a lot of these irrigation communities don't really have the funds or the resources to do it on their own, but they've gone out and written grants and they're able to capture some money and do these projects. So this 36-inch job we're doing here in Arizona was all grant money. They had to write a grant, had to prove why they needed it, but they quickly like called me. We talked about the project, and like 3 or 4 weeks later, they're buying pipe. It was pretty fast. So that's going to be a great example of saving water and providing more water to their community long term, forever, with really zero maintenance issues down the road, right? So canal conversions are big.
So are they just
I have a
laying
quick
that
question.
sorry, Dan, are they just laying that polyethylene pipe in that open ditch?
Yeah, it's a little more than that. They're going to have to probably go clear and grub and open up the ditch, and obviously they're gonna put the pipe in the ground correctly and backfill correctly around it. They're challenging projects because they're usually in pretty hilly, remote areas, where these canals were built 100 years ago. But once they do it, once they get it done, it's there forever. So every one of those is designed a little differently, but they're going to bury it in the ground.
Go ahead, Dan.
Mike, so my question is, you were talking about the leak-free and trusting that, and and excuse me, there's not a whole lot of people in front of large projects. I mean, like early on than you, right? You're one of the maybe 3 people in the industry that really know years down the line what's coming. Is it more people trusting polyethylene to be leak-free, or they are starting to finally realize other products are not leak-free? Like, what is the driving change, do you think?
I think it's a bit of both, Dan, but as we get in front of the engineers early, and if there's engineers on this call right now, I would say, let us come in and educate you. That's really what we want to do. We want to show you why it's leak free. We want to show you how we can make sure the fusions are done correctly. We want to show you quality control. We want to talk to you about, sizing your pipe correctly and making sure you have the right DR and the right diameters. We want to talk to you about how we handle thrust, right? And how we handle all of the benefits of HDPE pipe. But Dan, I think to your answer, I think it's probably a bit of both, but certainly as we educate. And one of the things I do when I'm in front of engineers and I go into lunch and learn, I always bring in a fusion sample, right? And I always have a little fun. I always throw $100 bill out there and go, all right, before we leave today, if you can break this fusion in half, you can't bring any tools in, you got to stay in the room. But if you can break in half, here's $100. Of course, that gets everybody engaged, right? I've only lost $100 one time. And it wasn't because somebody broke the fuse. It's because Gary Bouvet took my $100 and didn't give it back to me. So he stole it from me. He still owes me that $100. But it's fun because they actually get to see the fusion joint. They get to try to break it. And I'll tell you, as we educate a bunch of young engineers, which is really fun for me, they haven't actually seen this in person. That's when you get them out to a job site or a plant tour and the light bulbs just go off, right? So the next generation, they get it, they understand. I think we struggle sometimes with some of the old school engineers that have done it the same way forever, and they're not going to change. Okay, I get it. We're all probably guilty of that at some point, but for me, it's fun to watch the new engineers and go educate them. So that's really what we try to do early
Well,
on.
I've done a lot of seminars with your staff, and I love working with ISCO guys, Mike. But I will tell you to a T, about every salesperson I work with gets mad at me when I say, okay, if Peter Dyke's going to come work with you, you've got to bring along a 1.4 or a 2.6.
Yeah.
And you just got to carry that fusion machine into the meeting.
Sure.
And that's my rule. Your rule is you got to have, you bring in a fusion sample. I bring in a 14 or a 26. Because once Mike, you talked about that light bulb. Once they
Yeah,
see the double rollback bead coming together,
for
they're
sure.
like, the room goes quiet. They're like, oh my God,
Hey,
that's how
Peter,
we get the leak free.
I'll tell you another fun story, and I'll try to be brief. We did the same thing. I was in Colorado working on a project that has been around. It's been around since Kennedy. He signed it into law, right? Back in '64. This is how
A
long this
history
project
lesson,
has
Mike?
been. What's that?
Is this a history lesson we're getting today?
It is a little history lesson,
Nice.
Dan. Do you know who Kennedy was? Never mind. Anyway, so we're in there with a group of owners and engineers, and we're talking about this potential long pipeline that they're going to do. We bring in some big heavy wall fusion samples, 36-inch DR 11 or whatever it was. I mean, big, thick. Throw those on the table, and then we roll in a piece of pipe, a thin, sample piece of pipe like we do at our trade shows. We bring that sucker in to the conference room, and everybody gets to touch it and see it in the fusion joint. We go on and we have our meeting. Our contractors there, the engineers are there. By the halfway through that call, the one decision maker goes, "This is what we're putting in the ground." My contractor buddy kicks me under the table. He goes, "This is your project." So it's doing those kind of things to show people why, what the benefits are, but sometimes they've got to physically see it. You can talk about the math, you could talk about all the engineering, but man, you roll that in and show it to people, it's huge. So it was fun.
Mike, great story. We love to talk about the features and benefits of the product, but what you talked about with that canal conversion in Arizona, I mean, that's a real solution that you're giving to an owner. Tell me about some of the other solutions that you've provided, either in present day or in past years that could resonate with our audience.
Yeah, I'll mention a couple. So that canal conversion, we're competing against dirt, right? There's no existing pipe, but there's some other projects that we're doing. Um, Talking about a siphon project we just completed last year in northern New Mexico, up at the Navajo Nation. Existing siphon there was concrete and it was failing. It had been in the ground for whatever, probably 30 years or so. And they started having leaks and it was failing and so forth. We went in there with HDPE pipe, large diameter, really large diameter, 1800 millimeter pipe, DR 21, I believe it was. And it was 2,600 feet of that pipe, and we went in there and replaced concrete pipe with HDPE pipe in kind of a challenging terrain, open but challenging terrain, large diameter, fused it up with the McRoy Talon machine, and it went seamlessly, flawlessly. They now have a system that'll last them 100+ years, again, with zero maintenance, no challenges. That solved their problems big time. We've got a couple others that we're working on that aren't done yet, but there's one in Nebraska that we're working on that's over 100-inch diameter pipe. Same thing, siphon project. We're up against steel pipe, but we can easily talk about the benefits of HDPE versus steel. With steel, obviously, there's corrosion issues. The pipe's not always going to be full of water, right? There'll be periods where it'll be empty. What happens then, right? There's going to be scaling and corrosion. And what I learned a few years ago working on a project is when you put a steel pipeline in, obviously the installation method's going to be different, right? There's a lot of welding that takes a lot of time. So there's definitely a difference in install cost, but there's also a difference in overall maintenance. You got to chemically treat that. You got to make sure you keep the corrosion. You got cathodic protection, all of these add-ons that you have that can be done, but you don't have to do that with HDPE pipe at all. So there's a lot of benefits. And as we talk to owners and engineers, we got to make sure we're talking apples and apples, because it's really not. It's a different story. So we got to make sure we educate and talk to them about that.
And Mike, this is so intuitive that I feel, somewhat dumb even mentioning this on a public forum, but canals are by nature gravity fed, right? So they're already graded, they're surveyed. We know that they're going from high to low. And the projects that I've seen, people do two fusions, they do 100 feet the first day. And the second day they come back and they say, well, what if we fuse 500 feet and drag it? And then you come back a week later and they're trying to pull 4,000 feet of pipe in one, flop into the ditch at once. It's like, okay. It starts
Yeah.
getting hard because, the cranes and all the machinery out there, it's different for 4,000 feet. But I mean, in terms of productivity, I don't see any piping product being more productive on a canal closure.
Yeah, I think if we get in and talk about constructability on projects and educate the owners, engineers, and also the contractors, I think you're right. I think there is a big difference. Not on every job, but on a lot of these jobs, our constructability and our fusions and our quantity per day is so much more. Um, And there's a couple case studies I can talk about. I talk about the talent job we did in California years ago on the almond farm, right? We were going to race and compare on that. Our productivity was so good with the talent that we ended up not doing it. It was just fuse and go. I've done the same thing down in South America in a mining project. They were getting maybe one or two joints a day previously. We come down there and bring our technology. We get up to 6 or 8 joints a day. That's huge. That's like 3 or 4 times the production for sure. Um, the guys that we've talked about before down in Guatemala with a hydro penstock line, right? They were all steel. They were used to using steel all the time. We went down there and educated them and showed them how we could use HDPE and curve and bend and go up and down the mountains, eliminate a lot of elbows, and just increase their productivity. So you're right, Dan. I think that's a key part of it for sure.
Yeah, it's always so funny to me because they spend 10 years designing a project and then they want you to finish it in 3 months, you know?
Yeah, yeah, that never changes. Yeah,
Yeah, right.
So you talk about the McElroy equipment. We've got some data here that talks about their, the size below the Talon, which is the 2 meter diameter, which is 78 inches. Their T9 and their T9 is probably their most popular large machine, which does 0.9 meter or 36 inch. They also have the T12, which is 1.2 meter. So Jason Penland gave me these numbers that over the last 2 years, which is what we used on the pipe, so from 2023 to this year, the sales of their product in that two machine zone is up 207% in
yeah,
2 years. So if they're doing 20 units, they're doing 40.
yeah, yeah, Peter. I think that's totally accurate. I think that goes hand in hand with the data you talked about with one of our pipe manufacturers, right? Same thing. And we see it. I mean, I remember buying our first 36-inch fuse machine years ago, and that was a big deal. But today we have a bazillion of them in our fleet, and we're adding T1200s pretty quickly as well. I think that's where the market's going. And if you look at the global data for HDPE pipe, you know, in 2023, if we're talking about that the global pipe market for HDPE was a $21 billion market. They project that to be 34 billion in 2032. So we know we're growing. We're taking market share for sure. I think anywhere where there's infrastructure that has to be done and people want, back to our key buzzwords, sustainability, right? They want a pipeline that's going to last a long time. HDPE is a great solution for sure.
So you've mentioned this a couple of times, Mike, taking market share. Who are we taking it from? You've mentioned steel and concrete. Who are we taking it from?
Yeah, I think the plastics are taking market share. So if you look at PVC, they're probably growing as well. But when people want a leak-free, no gasket system, HDPE is certainly taking market share. But I would say it's taking it from the traditional pipes, ductile iron, certainly steel, concrete. Those are probably the big ones. And then you've got canal conversions that don't have pipe at all, so that's new. But I think we're definitely putting a hurt on some of, and we see that we're taking market share from our competition, and they're not happy about it. But there's a reason we're doing it, right?
So thank you. You said you had a fleet. ISCO sells stuff. What do you mean you have a fleet?
Yeah, so we certainly sell fusion equipment, but we have a fleet of rental equipment as well. So if a project needs to be done and you're not in a position to purchase a machine, we certainly will rent it to you or rent it to our contractors and go out and mobilize. So it's pipe, it's fittings, it's structures as well, it's fusion equipment, and then it's tying all of that in and making sure you have the proper quality control system, the proper installation methods, right? And make sure you have the proper testing of the system when it's done. We want to make sure the system is installed correctly from beginning to end. And when we talk to our customers and engineers about it, we will walk you through all of those processes.
All right, we got to close here because guys like you have told me, Peter, don't talk so darn much. Your podcasts are too long. I'm going to ask you one question, okay? And you got 90 seconds to answer it. What is Mike James' favorite project you've worked on in your career?
Yeah, I think that's an easy one. I think I've worked on some really cool projects, but I think my favorite project to date, and that may change in the future, is the Guatemala job that I did, because it started with an engineer, and we did a basic engineering call up in the Northwest. A couple years later, he calls me and goes, "Hey,
Wait, a Guatemala project in the northwest of the United States?
yeah. The engineer was working on a project in Central America with this particular owner. He just happened to be in the Northwest, so
Oh, okay.
we were knocking on doors and visiting people, and we went in there and had a great visit and did a little lunch and learn, and then down the road he calls me and says, "Hey, I've got a project where these guys want to come up and see. Do you have something in Florida or Texas or somewhere close for them?" I said, "Well, we've got one right now in Oregon. We're doing a big irrigation job in Oregon with 54-inch diameter. Why don't we have them come up there?" They did. Met them up there the next week. This was like on a Thursday or Friday. Took them out to the job site. They were touching 54-inch pipe HDPE for the first time. And I remember there was two Guatemalan guys that are like brothers to me, and a guy from Liechtenstein. Dan, look that up. You know where that's at? Small country. And this guy Herman has put pipe in all over the world, in the Congo, in the jungles, here, wherever. He was from Liechtenstein, had never done HDPE, and he was an old guy, old tough cookie. But we convinced him, and Rudolph told me, "You've got to convince Herman. He's my pipe guy." I flew down to Guatemala the next week. May have had a little bit of rum, but we ended up walking the job site, sweating our butts off, and talking to him about uh, you don't need elbows here. We can bend pipe here. We can do this. We can do that. Halfway through the job, they go, "Sorry, stop, time out. You're telling me we don't need elbows here, there? Mike, is this real?" I go, "It's real. You saw it last week." And so over the course of several visits, we ended up selling that job and making some good friends, and it was fun. And then from that one project, we were able to bring other irrigation companies, other hydroelectric companies in from Guatemala, and we ended up selling like 5 projects from that one engineering call turned into one project, turned into like 5 projects. So for me, that meant a lot to me. That was fun.
Well, that's a great story. We had another webinar this week, and I was able to tell a similar story. The Hampton Roads Sanitation District, Greg Elwood, your former colleague, and I did a road show 8 years ago at HRSD, and we were told by the head engineer that, nice idea, but not happening here. Well, Greg kept at it, and within 2 years, we had our first pilot project at HRSD. And then in 2023, they commissioned the Swift project, where an HDD was drilled underneath the James River, 5,700 lineal feet, that Garney, one of your customers, did. I know you weren't involved in that job, but that is a very rewarding project for me. We had nothing to do with the design of the Swift project underneath the river, but we had a lot to do. Your buddy Greg Elwood and I had a lot to do with orienting HRSD to HDPE pipe. So what a feel good. HRSD's premier pipe they use today, they still use other ones, is polyethylene.
Yeah.
It's so rewarding when that happens. So to hear that Guatemala story warms my heart.
Yeah, I think Greg had a characteristic in him that I share as well, and I've been called this over the years: pesky. You got to be pesky, which means not too aggressive, but just aggressive enough, but to educate, right? So I would say, maybe closing comments, if there's some engineers on this call, please allow us to come in and educate your staff. We'll give you some credits, right? Some PDH credits. And then for our industry colleagues that are on this call, make sure you're doing that. Yeah, you don't have to be an ISCO guy to do that, but go out and educate. I know we're all worried about what's in front of us today, but take some of your time and make sure you're educating and teaching the community.
Well, wonderful talking with you. Mike James is mike.james at isco-pipe.com, I believe. Is that correct?
Yep, you got it.
So that's how you get a hold of this guy. And he is my go-to guy. So when I have an issue that I don't understand in the field, I call Mike James. So Mike, once again, so great to talk to you. Have a safe journey the rest of the day.
Thanks for having me on. Appreciate it.
All right, welcome back to the second segment of this podcast. And I have the pleasure of introducing Mathew Danysh from AGRU. Hello, Mathew.
Hey, how's it going, Peter?
Hey, it's great to see you in this podcast format. You're a regular with the webinars. And, you've distinguished yourself here the last few years, Mathew, when we've been talking about the medium, large, and double XL pipes. You guys are the go-to company and you're the voice. So thank you for sharing your knowledge and wisdom with us.
Oh, it's appreciated. So, just a little bit about myself. I've been with AGRU for about 11 years now. Been in polyethylene all my life. Actually started co-oping in a resin manufacturing facility in Pasadena, Texas, many years ago, and joined AGRU recently, basically recently, 10, 11 years ago, for the pipe division of AGRU in the U.S. And since that time, we actually installed a large diameter HDP pipe factory in Charleston, South Carolina, producing large diameter pipes, 10.5 feet in diameter, and then also with heavy wall pipes. So smaller diameter pipes with heavy wall, something that the industry hadn't seen before. And this is really something that has taken the interest of a lot of people, municipalities, to get the higher pressure rating on these larger diameter pipes to be used for main lines and transmission lines. So yeah, it's been busy. This is a great industry to be in right now with all the growth that we are seeing, and we're excited to be here.
So thank you for telling us a little bit about yourself, Mathew. Tell us about AGRU. AGRU is relatively new to the Alliance. You guys have been with us about 3 years, but you've been in the industry a long time.
Yes, AGRU started, 1948 in Europe, 77 years ago, and they actually started extruding polyethylene pipe in 1962. That was like when the actual HDP was actually in the formation process. And then in 1966, they started injection molded polyethylene pipe fittings. So we've been around HDP pipe for a very long time, from small sizes, then developing them all the way up to the 10 foot in diameter. So this is not something that we just discovered overnight in the last 8 years, but something that has been worked on for many years.
Yeah, so cool. All right, so a little bit about the company. Tell us about some of your products. One of the reasons I'm so fascinated with your company is because you make things in sizes, in DRs that, very few people can even imagine.
Yeah, so we have been making large size pipe. We call our XXL division of pipe. Currently, we're making 3260 millimeter, which is 128 inches OD, and that's up to a SDR 21. And with that type of technology, we're able to use the smaller diameter pipes as well. So if you go down to like a 63-inch pipe, we're able to make 63-inch pipe with a 6-inch wall, which is around an SDR 11 pipe for 200 PSI. So those are pipes that can be used in for transmission lines and main lines for municipalities and water usage.
Tell us about your fitting line, Mathew.
Yeah, so fittings, so we basically, whichever pipe size we make, we're able to offer the fittings to go with it, from T's, elbows, flange adapters, and even electrofusion couplings, which we now can make up to 2 meters in diameter. So we have different methods to put pipe systems together to meet the needs of the whole system, from takeoffs, elbows, T's, flange connections, and converting to other pipe systems.
Come on, you're telling me you can do a 2-meter diameter electrofusion coupler?
Yes, this is something that we started about 5 years ago when we went to a 63-inch e-coupler. And then it's like, well, how far can you go? And so really the challenges on these e-couplers is not the e-coupler. The e-coupler is actually easy. What's difficult is making the pipe that has consistent OD, because the e-coupler requires a pipe diameter to be very consistent. So as long as you can meet the tolerance range of what the e-coupler can provide, then you can actually make an e-coupler any size. The limitations for e-couplers is the tolerance level of the HDP pipe. And as you can see from the charts, as you get larger in diameter, the tolerance range for OD increases. So that's always been the challenge with e-couplers, is as you get a larger diameter pipe, the spec for tolerancing gets very wide. And so
Wow.
then that makes it difficult to match that up to an E-coupler, because an E-coupler ID to a pipe OD has to be very tight in order to get the mating surfaces of the wires to the OD of the pipe.
Yeah. So, I don't really want to spend all this time on electrofusion, but how do you scrape a wall, a 2-meter wall?
Oh, once you get to those sizes, it's no longer manual. It's all automated. Basically, we have an automated system where you have a rotary cutting tool that is on a chain wheel around the pipe. And you hit the power button, it basically goes and eats the material off, or I should say eats, because it looks like a little beaver going 90 miles an hour around that pipe, chewing on the pipe. But yes, it's automated process. So once you get to larger sizes, you really need to take out the human factor in these pipes because of the sizes are so large. And so yeah, it's just a different way of doing it.
What about the processor? What does that look like? Is
Oh,
it
the
a
processors
semi-truck?
are very large. No, it's not a semi truck, but it is quite hefty. There's a lot of the transformer inside these units is quite substantial, and it requires higher voltage. So basically, the way we get around the size is we have a higher input voltage coming in from your AC generator to create the current in order to create the heat in the electrofusion coupling, and you do one side at a time so that the amount of power is reduced.
Wow. Well, the first half of this podcast was with Mike James, and Mike, as you know, is with ISCO, and you partner a lot with ISCO. And Mike mentioned that New Mexico job, and I understand that you guys worked on that with him. That's one that was fused with the Talon, and that was a siphon project. Tell us a little bit about the fittings that AGRU made for that job.
Yeah, so for that project, the 1800 millimeter diameter pipe system there was a number of elbows included in that project, and then there was some reducing T's. The reducing T's which was very interesting because they wanted full pressure rating for that SDR21, and so in order to get to that higher pressure, we actually used something called a machined billet reducing T. So basically, it was a large billet of material, so a hollow bar, and we machined it to make a reducing T with it, so that they could put a man wave for clean out at the bottom of the siphon. So basically at the bottom of the siphon, there was a T, the manhole, it's fully pressure rated in order to access the pipe systems for cleaning and maintenance purposes.
That's fantastic. I mean, what does a billet T before it becomes a T? I mean, how big a piece of slug of resin is it?
It's around 2.2 meters in diameter on the OD side. And so basically we take a hollow bar of material that has that type of OD, and then we just machine it down to the 1800 on the ends, and then have a top portion that has the reduced diameter. I believe for that one was 1200 or 48 inches that we reduced it down to.
Wow. And how long a process is that? Is that like a day, half a day?
What takes the longest is the alignment to put into the CNC machine and the programming and all of that. But yeah, the machining takes about a day.
Wow, that's exciting. So basically what you're telling me is that you are making up to 10-foot diameter DR21 pipe, and you also can make the fittings to go along with it.
Yes, because it's useless to have pipe without having the fittings. Because you have to tie it in, you have to change your directions, you have to tie into other components. So yes, it's not just the pipe, it's the overall system.
So one of the projects that I learned about last year, Mathew, was ISCO and AGRU worked on a project, and I've been saying for years that just make your trench and drop your pipe and bend it in. But in some of the larger diameters, you've told me that it's actually beneficial to use a fitting and not bend the pipe. I don't know if it's because it's more dangerous because it's big and heavy, or what. So what's the logic on an 11-degree fitting on a big piece of pipe? Why isn't my counsel that I've been using for years in the smaller diameters apply in the big diameters?
It does. The reason why you would want to use fittings if you have not as much real estate to do a bend. So if you're tight cornered, a lot of these utilities or whatever have a very limited easement to work in. So it really depends on the overall system. If you have enough space, if you have enough acreage, then yeah, you probably would never need a fabricated elbow. You could actually just bend the pipe, because even our large diameter pipes do have a bending radius, and you can bend them. We've seen, bending radiuses of, 30 times the diameter of the pipe without any problems. Just using a big backhoe to pull, move the pipe into place.
Oh, got it. Okay. So when you guys are using those fittings, it's because either you can't make the trench the way you don't have enough real estate to make the trench bigger, or there's some constraint where you've got to drop in a fitting.
That is correct. Yes.
Interesting. All right. You mentioned earlier, Mathew, a little bit about growth in the industry. We've got a lot of soldiers out there, a lot of salespeople working for our member companies talking about medium and large diameter pipes. The Alliance is talking about it. You're talking about it. What kind of growth are you seeing, and in what diameters? Where are we making headway?
The headway is definitely with the size range 48 to 63 in our heavier wall pipes. There's really good growth there, even like the 42 dips pipe sizes. These pipes are, being designed for systems that are already in place, replacement, and also for new systems going in as well. So we're not only looking at replacement of existing assets, but new projects as well.
Yeah, my sense as well. A lot of these new projects are, like canal conversions or bringing water from a river 100 miles because we've chewed up the aquifer. There's no aquifer left, or it's too expensive to drill deeper. So you're seeing it at AGRU as well.
Oh, absolutely. Yes, canal conversions are huge because there's so much loss of water to the atmosphere and trickling into the groundwater from open trench canals that they just need to be replaced. There's so much water that's being lost in those open canals that we could actually gain by putting them in HDP pipe.
So who is it? I'm not so concerned about the contractor. I'm concerned about the owner. Who are the owners of these big diameter jobs, 48 and above? Are they all municipalities? Are they companies? Are they mines? What applications are these going in?
A lot of them are irrigation districts. So there are irrigation districts all over the US that are independent, basically being represented by farmers. And so that is a large chunk of the open trench canals. And then there's some really big canals like in Southern California, the one that runs from the Boulder Dam to Los Angeles. That's a big one that we need to do something about. So that I believe that's owned by a conglomerate of different organizations.
Okay, so going after these municipal entities is a good thing. Educating them more and more about what polyethylene can do. It can do it better, cheaper, and it's going to last a whole lot longer than legacy materials. Am I getting that right?
Oh, absolutely. There's no question if you're looking at longevity from a corrosion standpoint, from an installation standpoint, that HDP is superior to any other system.
That's exciting. As I look at other municipal entities and projects, you've got that New Mexico Hogsback project. What are some other projects that you're proud of that AGRU's been involved in that our audience could learn from?
There was projects done in Vernal, Utah with the project there for irrigation district.
Tell us about the Vernal job.
Yes, that was one that was done a few years ago, and that was with 2-meter pipe. and basically connecting a reservoir to farmers out in the field. So one of the great things, other things that you benefit by putting a canal into a pipe is you get the benefit of the head pressure. So basically, once you attach it to the reservoir head pressure, then you can deliver water to farmers that's pressurized as well. And not only pressurized, but it's cleaner, meaning that it's not going through a muddy canal and trash. Unfortunately, for some of these canals, just people throwing trash out the window or getting blown with the wind, you end up with a lot of trash in these irrigation canals. And that causes farmers a lot of problems because you end up with a plastic bag that ends up in the suction system, gets caught in their equipment, plugs up some of their nozzles and things like that. So by putting the water in the pipe system, you keep it away from the environmental impacts of pollution and things like that that can cause problems for the farmer, and you're delivering it under pressure. So basically, when you attach it to a reservoir, you're able to provide it to the farmer under pressure, so they don't have to actually put a pump to pump out the water and then pump it through their system to their
Well, the
irrigation
reservoir would
beds.
have to be higher in elevation, right?
Oh, yes, yes, yes. So most of these projects that are canal driven are coming from higher up in the mountains, from reservoirs that have some significant head pressure to them.
Thus, the engineers put the reservoirs at higher elevation so they don't have to worry about pumps.
Correct.
Yeah. Okay. What one thing would you want? I mean, most of the people that listen to these podcasts are in our industry, so they know who AGRU is already. What one thing do you want the industry to know about AGRU? What would really help you guys and your messaging?
Well, the messaging that we have is that it is available. It is a pipe system that is proven for many, many years. Over 60 years now that HDPE pipe has been out there. It's functional and it works great. And I think that people just have a sense that it's very difficult to install because you have to have this sophisticated welding machine to weld the pipes together and blah, blah, blah. But at the end of the day, even though with all of that process, you end up with an HDPE pipe that is homogeneous. There's no other materials involved. There's no fancy flanges that are put together. There's no glue. There's no other materials involved in the actual system itself. And so when you look at an HDPE pipe system, it basically can last forever. We tell it 100+ years, but with the resins that we're making now, and which have just been continued to be improved over the years. In the last 50 years, the technology and improvements of resins is just incredible. And when you look at the other legacy materials that are out there, they really haven't been approved. They're basically what they are as they were 50 years ago. And whereas HDPE is just advancing. And what that tells me is that they've peaked out. So the other piping materials have basically already exceeded the expectancy and the need to improve. So we're looking at HDPE as basically the material of the future.
Yeah, and that future is today. You're so right. We've made tremendous gains in my view, three major areas. One is the material properties have been expanded tremendously, so its ability to withstand chemicals and chlorine and all that. The installation method. I mean, to your point earlier, Matthew, we're doing 54-inch diameter horizontal directional drills. What? That's extraordinary. And finally, we have the ability that AGRU is on the cutting edge of this, of making 6-inch wall thickness. So very high pressure, large diameter pipes. So it is extraordinary. You're so right. It's exciting.
Yeah.
Go ahead.
Oh, yeah. And getting into this horizontal directional drilling, that is such a great tool for the industry because it minimizes the impact of the community. you don't have a big old ditch being dug through your yard and all of that. You basically pop in one side, pop out on the other, and you're able to accomplish much more pipe systems installed with a smaller footprint of disturbance.
Yeah. Okay, to wrap up, I've got one final question for you. I asked Mike James this as well. If there's any one thing, whether it's a project or a situation or whatever, that you are very proud of or you thought was very cool in your career in the last few years, what would that be?
Oh, it's definitely converting these open trench canals into pipe systems. Like I said before, it's such a blessing because you're able to do so much with that application, and you basically increase the amount of acreage that's available to the public by uh, providing additional real estate. And so, yes, with keeping the water cleaner, keeping it under pressure, and minimizing footprints, it's all part of the process of something that is absolutely, in my mind, something that is a benefit to the overall benefit of the community.
Yeah, well, so you're talking about it just as a category, the fact that the market, the irrigation entities, the municipalities are realizing they don't have to convey water in an open trench and lose 40% of it. They can put it in a fully monolithic, leak-free polyethylene pipe system and have basically no leakage.
Absolutely.
You know, I thought you were going to say the Hampton Road Sanitation District job you did with Garney last year, where they did that 48-inch drill underneath the James River, and now they're doing 54-inch. Your 54-inch DR11 pipe open cut to finish that. I think it's like 6 miles.
Yes, that's a very interesting project as well. Absolutely. There's just so many of these out there. It's
Yeah.
hard to pick one.
So true. Okay, so how does somebody get a hold of Mathew Danysh?
You can call our corporate office, or you can shoot me an email. It's all part of, if you go to our website, agruamerica.com, you can access all the information about our products, and my contact information is in there as well.
All right, so you're not only a technical expert for AGRU, you actually help engineers when they have large diameter design challenges.
Absolutely.
Is that part of your role?
Absolutely.
Yeah, that's very cool. Well, Mathew Danysh, please come back and see us on the webinar program. And then, of course, let's do another podcast next year. Mathew Danysh, AGRU, we're so pleased to hear from you today.
Great to be here.
All right. Till then, see you on the road.
All right.